What's going on, everybody? Zane here, back with another video. For this one, we're going to go over question number 937, which is reordering data in log files. So we're given a bunch of logs, which is just a bunch of strings, and each log is a space delimited string of words, meaning they're separated by spaces, and the first word is going to be the identifier, excuse me. So we're going to be given two sets of logs, or two types of logs, which will either be letter logs or digit logs, which of course sound like exactly how they should be. So either letters or just digits. So we have a couple of rules here. The first is letter logs will always come first before digit logs. The second is that the letter logs are sorted lexicographically. And what that means is if we were to give or assign them some sort of numerical value, let's say, I don't know, A was 0 and then B is 1, that's actually a terrible example, but if we were to compare A and B, the value of that would be 1, because if we're comparing it, that means B is just 1 ahead, so 0 would be, I guess, lexicographically in that order, so A would be first. I just botched that explanation completely, but anyway, they're supposed to be sorted lexicographically for letter logs, and if the contents are the same, then we sort them lexicographically again, but this time by their identifiers. And then the third rule here is that the digit logs will always remain in their relative order. So let's think about how we're going to tackle this. We're going to use a unique property of the arrays sort method. So let's first do that. I'm just going to get this out of the way because this is just one piece that is a little, I'd say it's a little, the learning curve for this piece alone for me was pretty tough because I was trying to understand why exactly we use this rather than just looping through all of the strings in the string array. But we didn't need to do any of that, and I know that from doing research and figuring out that, hey, we can just do a lambda and kind of just do some of our operations inside of this lambda. So let's think about this now. We're going through and we have basically two logs that we're comparing, and then it'll continuously go through the rest of the logs. So what we first want to do is we want to establish what is the identifier, because that's what everything starts with. Now the identifier is going to start for every single log. What is the identifier? And the identifier we can establish by taking advantage of one of the mechanics, so to say, of the logs, which is the space delimited piece. So if we were to first get some value, let's say index where space starts, that would mean that that is the index where our first space is, meaning everything before that should be our identifier. So if we can get the index or the value of this, then we'll know where our identifier and the rest of our log starts. So we'll say, since we're doing our first piece, we're going to be doing two logs, so log 1 and log 2. So I'm going to be naming things similarly with a 1 or 2 at the end. So index where space starts 1 is just going to be log 1 dot index of, and then wherever the first space is. Now our identifier is going to be a string, so identifier 1 is just going to be the log1 dot substring from the beginning all the way up to this index, because that's where the first space starts. Then the main log is just going to be main1 is just going to be log1 dot substring of whatever that index is plus 1. So we've established where exactly our first space is, then we've established where the identifier is by taking the substring of log1 starting from the beginning all the way up to where we just got this index. And then the rest of the log is just going to be everything after the identifier, which would just be the substring of that index plus 1 onwards. So now we've got everything for that. So let's do the same thing for our second log. So let me actually copy all this for the sake of time. Copying is not the best way of doing things, but in this case, we're just going to do it. I'm going to change everything to 2 because we're talking about log 2 now, and I want to make sure that things are named according to the log we're taking a look at. So exactly the same thing we're doing, except for log 2. Now, we've identified where the space is, what the identifier is, and where the main log begins, so everything after the identifier. Now what we could do is we could establish whether or not a log is, we're essentially, let me just reword that. We're going to need to know whether or not our log is a digit log or a letter log, because we can take a look at our rules. There are specifics that we need to go by. So let's create 2 booleans. We'll say is digit log 1, and I'll create another one, is digit log 2. And what we'll do is, we know that the digit logs start with numbers and will only be numbers. We know that the letter logs will always be lowercase English letters. So if we were to use the character.isDigit property on the first letter of the log itself, which would be the main log, we get just the first character, and if that is a digit, well, then it's a digit log, because there's not going to be a mix. And we'll do the same thing here. We'll do character.isDigit, and we'll just do main2.char at 0. So this will tell us whether or not a log is a digit or not. Now, if the log is not a digit, so let me actually just properly format this here. So if is digit log 1. So if it's not a digit for the first log and is not a digit for the second log, that means that we are currently at a situation where we're comparing 2 letter logs. So here we're comparing 2 letter logs. And let me just make sure here, finding where the identifier starts. Sorry, I should have put this up earlier. So now here we're saying that, okay, if both of them are not digit logs, that means that both of them are letter logs. So now we need to have some comparator value. So the comparator value is just going to be comparing the values of the main logs, because we're being told here that the letter logs are sorted lexicographically by their contents. So that would be the main portion. So we'll just say that the comparator value is just going to be main1.compare2 main2. And what compare2 does is, like I had mentioned earlier, if there was a few letters A, B, C, and we were to say compare A compared to B, that means A is going to go first because A comes before B, but we only know that conceptually because A, B, C, so A comes before B. But if we were to assign a value to that, we could do that with the compare2 function, and that'll tell us, okay, there's a specific value, such as, I don't know, maybe -1 or 0 or 1, that will return that value depending on where it is lexicographically. So our comparator here does that for us using the main portion of our log, excluding the identifier, because we're not necessarily worried about that just yet. So we're comparing the main log and the main log. Sorry, we're comparing the main log 1 and the main log 2, and we're getting that value. Now if the comparator is 0, that means that there is no difference between the 2 main logs. Then, if the contents are the same, this is where we're at. Then sort them lexicographically by their identifiers. So now what we could do is, so if the comparator is equal to 0, then we just need to return the comparing of the identifier 1 with identifier 2. And then down here, we can just return our comparator. Now, we need to deal with our digit logs. So we're done with our letter logs, and we want to do that first because that's what we're being told. So now let's take a look at our digit logs. So we can just do a one-line kind of ternary statement where we could say return is digit log 1. So is the first one a digit, or the first log a digit? And then inside of that is the second one a digit. So now if both of them are digits, we're being told if the digits maintain their relative order. So we're not necessarily concerned with whether or not if they're both digits, then we keep their order. So we're not concerned with making some change if both of them are digits or digit logs. So we'll say 0 here. Now, if we're in the case where the second log is not a digit, that means we would need to put 1, because we're saying, is the first log a digit log? Okay, then is the second one a digit log? If it is, then return 0. If it is not, so is log 2 a digit? If it is not a digit, that means we're going to return 1, meaning pushing it to the right. And then our last situation would be really, okay, if both are not, then it will just be -1 to account for both being not digit. Now, lastly, we need to actually return something. So we've already done all that through our lambda function and sorting. So right out here, we can just return our logs. Let's submit this. And that's it. So we're using the power of lambda here by comparing constantly 2 logs, getting the identifiers by using the space, getting the rest of the log using that identifier, doing the same for both, checking to see are they digit logs or letter logs. Now, if they're definitely letter logs, okay, compare them. If there are no changes or they're both exactly the same, okay, compare them again, but this time on the identifier. And then lastly, return the comparator here. And then at the very end, we'll say, okay, are both of them digit logs? All right, return 0. Is only the first one a digit log and the second one is not? All right, it's going to be a 1 to push it to the right. Are both of them not? All right, we're going to push it to the left. And now we'll just return logs. Anyways, guys, I hope that made some sense. If you guys have any questions, comments, feedback, or if you know how to optimize this, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.